Hello everyone, in this video we'll study about the working of the hand-crank magneto generator. In the previous video we studied the working principle behind the hand-crank magneto generator. Now let's look at the working of the hand-crank magneto generator. So to better understand the working of this apparatus, let us divide this apparatus into three parts, that is part 1, part 2 and part 3. Let's start first with part 1. The part 1 consists of the hand crank, the large gear and the small gear. When I move the hand crank, it rotates the larger gear. The large gear in turn rotates the small gear at a greater speed. The part 2 of the apparatus consists of the 3 horseshoe magnets and the armature coil. In this, the coil rotates the magnetic fields of the horseshoe magnets. As you observe on the screen, as the coil rotates in the magnetic fields of the horseshoe magnets, the magnetic flux changes with time, and as a result an EMF is induced in the coil. This EMF in turn produces a current. The rotation of the coil and the simulation indeed summarize the Faraday's law of electromagnetic induction, which states that whenever the magnetic flux linked with the coil changes, an EMF is induced in the coil. Furthermore, you may have observed that in part 1 of the video, I termed the coil as the armature or the armature coil. In this apparatus, the armature consists of the coil, a cloth and steel cylinder. The conducting coil in this apparatus is wrapped in a piece of cloth which is then placed in a steel cylinder. This process is also called lamination. The function of laminating the coil is to prevent energy losses due to any high temperature, eddy currents or hysteresis. The function of the cloth is to insulate the coil from the steel cylinder. Before moving further, let's discuss how the circuit is connected. Now, in this apparatus, the small gear is connected to the armature coil, which is then connected to a collector ring. This collector ring is connected to the brushes, which then are connected to the light bulb through connecting wires. The part 3 of the apparatus consists of 2 brushes, the light bulb, connecting wires and safety screws. The brush 1 in this apparatus is capped with an insulator. However, the brush 2 is a conductor. As you observe on the screen, when the coil is not rotating, there is an air gap between the 2 metallic plates. However, when the coil is rotated, the brush 1 is pushed forwards, which then completes the circuit. Therefore, it is important to note that the function of brush 1 is to complete the circuit. However, the brush 2 is the actual hero in this apparatus, as it is through which the entire current flows. Moving on, you may observe that there are 2 safety screws which are located on the right side of the light bulb. These safety screws are in fact rounded. The function of the safety screws is to protect the apparatus in case a large current flows through it. In case the cloth between the conducting coil and the steel cylinder is torn apart, there might be chances that the conducting coil and the steel cylinder come into contact. This contact could lead to a potential damage to the apparatus. Therefore, the safety screws in this case prevents the damage to the circuit by providing an alternate path to the flow of current. To summarize, the hand-crank magneto generator works on the principle of electromagnetic induction. When the hand crank is moved, it rotates the small gear, which is then connected to the armature coil, which moves in the magnetic fields of the horseshoe magnets. Due to the rotation, an EMF is induced in the coil, which then produces the current. This current is then transmitted to the light bulb through the brushes and the connecting wires. I hope this video was useful. Thank you for watching.